Hello, today we will be discussing screw gauge. Screw gauge. Before discussing screw gauge, let's have idea about screw. As we have seen, this is an ordinary screw. It's an ordinary screw and it goes threads over it. So there are grooves, you can see. So there are grooves and these are called as threads. These threads are at equal distance from each other and the distance between two consecutive threads. That is, if this is the screw and these are the threads, the distance between two consecutive threads, it is called as pitch. So distance between two consecutive threads is called as pitch. If you measure the distance between two threads, for example, I am measuring distance of 5 threads, it is around 5 mm. It is approximately about 5 mm. So distance between two consecutive threads, between two consecutive threads, let it be 1 mm. It is approximately equivalent to 1 mm. So pitch of the screw is 1 mm. Now, for example, this is nut and screw. So initially, this is the initial position. So I have marked on the nut, I have marked a line and a line on the screw. Through this we can see whether how many rotations we are providing to the screw. So for example, I am giving it one rotation. This is one rotation and how much distance it has moved linearly towards its axis. So how much distance it has moved? It is equal to 1 mm. It is equal to 1 mm. That is the distance between two consecutive threads. So the linear distance moved by the screw, in one complete rotation. The linear distance moved by the screw in one complete rotation. It is equal to the distance between two consecutive threads, and that is equal to the pitch of the screw. So pitch of the screw is defined as distance between two consecutive threads or the distance moved by the screw linearly along the axis, we can say, when the head of the screw is given one rotation. When the head of the screw is given one complete rotation, that is called as pitch. Now see here, in one rotation it has moved 1 mm, two rotations 2 mm, three rotations 3 mm, four rotations 4 mm. So this linear or axial movement of the screw, we can make use of it in measuring the length or the diameter of small objects. So this can be used to measure the small lengths. Now you can see if I am giving 1/4 rotation, this is 1/4 rotation. So distance moved by the screw will be, see here, in one complete rotation, distance moved equal to 1 mm. In 1/4 rotation, only 1/4 rotation, the distance moved or the axial movement is in 1/4 rotation. The distance moved will be 1/4 mm, that is 0.25 mm. Or in half rotation, it will be, in half rotation, the distance moved will be 1/2 mm, that is 0.5 mm. Now for example, I have divided the head into 100 parts, 100 divisions I have divided. Now only one division I am rotating, that is 100th part of the complete rotation I am giving, that is 100th part of rotation, that is complete rotation of one rotation. So in one rotation it has moved 1 mm. Now I have divided the head into 100 equal parts. 100 equal parts I have divided, and I am moving the head by just one division. So how much rotation I have given? That is 100th part of the one rotation. So the distance moved, the linear distance moved by the screw will be 100th of 1 mm. So least count will be, the distance moved by the screw will be 0.01 mm. 0.01 mm. Therefore, we can say when I am rotating by one rotation, it has moved by 1 mm, that is pitch of the screw. This is pitch of the screw. It has moved by 1 mm, and this is circular head. This is circular head, and I have divided this into 100 parts. Now, if I am moving it by one division, the distance moved linearly will be 100th of 1 mm, that is 0.01 mm, and this is the least measurement we can make using this screw. This is the least measurement we can make using this screw. Or when we are rotating by just one division, it has moved 0.01 mm. This is the least distance it can move when we are rotating by one division. So this is the smallest measurement of any length that we can make using this circular head or using this screw. So this is called as the least count. So the least count of the screw, the least count of the screw, that is the smallest measurement we can make using this screw of the screw, is the distance moved, is the distance moved along the axis, that is the linear distance moved along the axis of the screw, is the distance moved along the axis, that is the linear distance along the axis, when we are rotating it circular, when we are rotating the circular scale by one division along the axis by it, that is by the screw. It in rotating the circular scale by one division. So I rotated by just one division. We have divided this into number of divisions. Now as I am rotating by just one division, how much distance this screw has moved linearly, that is along the axis it has moved, that distance will be the least count of the screw, and that distance will be equal to pitch of the screw, least count equal to pitch of the screw, pitch of screw divided by number of divisions on circular scale, number of divisions on circular scale. This is called as least count, that is the smallest measurement we can make using this screw. Now we can take certain examples. For example, first, if the screw moves by 1 mm, the screw moves by 1 mm in one rotation. When we are giving one rotation to the screw moves 1 mm, that is the linear distance, that is the along the axis it moves by 1 mm, that then pitch will be 1 mm. And if there are 100 divisions on it, so number of divisions equal to 100. So we have to calculate the least count. Least count will be, that is if you rotate it by just one division, how much distance it has moved linearly, that is along the axis. Least count will be pitch divided by 100, and it will be 0.01 mm. This is the least count of that particular screw. If for example, if we are giving two rotations to the screw, certain screw is there different from this one, and the distance moved is 1 mm. In two rotation it has moved 2 mm. So in one rotation it will move half mm, that is 0.5 mm. So pitch in that case will be 0.5 mm. So what we have done, the screw moved 1 mm in two rotations. So in one rotation it will move half mm. So pitch will be 0.5 mm, that is how much distance the screw has moved linearly along the axis when we give the screw one rotation, when it is moved by one complete rotation, or the distance between the two threads, that is the pitch. In that case it is 0.5 mm, and if we are having 50 divisions over it, so number of divisions equal to 50. So here the least count will be pitch divided by number of divisions, that is, so it comes out to be 0.01 mm. If we convert it into centimeter, it will be divided by 10 again, 0.001 centimeter. Here it will be 0.001 centimeter. Now see the third one. Now if I am rotating the screw by 2 divisions and the linear distance moved by it is 1 mm, then which will be, again it will be 0.5 mm, since the screw moved 1 mm in 2 rotations, and let the number of divisions be 500 this time. Number of divisions equal to 500. So this time least count will be 0.5 mm divided by 500, and it comes out to be 0.001 mm, or in centimeters it will be 0.0001 centimeter. That is how much? 10 raised to power minus 4 centimeter. In meter it will be 10 raised to power minus 6 meter, or we can say 1 micrometer. So its least count is 1 micrometer, and if this case is used in screw gauge, then the screw gauge will be called as micrometer screw gauge. When the least count is 1 micrometer, then that screw gauge will be called as micrometer screw gauge. So now we will be discussing screw gauge. This screw gauge is based on the principle of screw. This screw gauge is based on the principle of screw. Now this screw gauge is used to measure the very small lengths. We can measure very small length. For example, diameter of a wire, very thin wires that we can measure its diameter using this screw gauge, or thickness of a paper, and it can measure up to accuracy of about third place of a decimal of a centimeter, that is 1,000th part of a centimeter. It can measure accurately up to that. We can discuss the screw gauge. Now you can see it is having a U-shaped frame. It is having a U-shaped frame. So this is the U-shaped frame. It is having two ends, one end, second end. This one end, it is having one flat end. This is the flat end. This is called as stud A. We name it as stud A. The other end, we have the nut. And a sleeve attached to it. A nut is there and a sleeve attached to it. Now you can see it is threaded from inside. The nut and the sleeve. Here it is threaded from inside. There are threads inside. So this is nut and sleeve arrangement, and this sleeve is graduated. You can see one reference line is there. This runs parallel to the axis of the screw. This line, this reference line, or we call it as the base line, it runs parallel to the axis of the screw, and this forms as the main scale. This is our main scale on screw gauge. So we have the nut and sleeve. The sleeve is graduated in mm. So we are having one baseline, and this baseline or the reference line, it runs parallel to the axis of the screw. And this forms our main scale. Now you can see the second arrangement. This is the screw. You can see the threads inside, and this is the head of the screw. Here we are having this hollow cylinder as the head of the screw. We call this hollow cylinder as thimble as well. And you can see this hollow cylinder is graduated at equal distance, and it is divided into 100 parts. You can see 0 and 90 up to 100. So this circular scale is divided into 100 equal parts. Now this is our circular scale, and this hollow cylinder is called as thimble as well. Now you can see the axis of the screw, it is parallel to the baseline. This baseline runs parallel to the axis of the screw, and when we are rotating the screw inside, as I am rotating the screw, this is the circular scale, we rotate the screw using this arrangement. This is called ratchet. This is one screw, so we can rotate the screw using ratchet. There is a function of this ratchet as well. As soon as this flat end, that is B, touches the stud, as it touches the stud, you can hear the sound. As it touches the stud or any object is being placed, and so you can see the screw doesn't move further. So this ratchet helps in not wearing or tearing down of the threads of the screw. So when the object is in between, or when this flat end B touches the stud A, the screw linearly press against the stud A or the object. Now this ratchet prevents further rotation of the screw, and any object that is held gently between the stud and the flat end B. So this is our screw gauge. So we can get the reading from the main scale, and then which division is coinciding with the baseline. So we will have two readings, the main scale reading and the reading from the circular scale. So main scale reading and the reading from the circular scale, that is which division is coinciding with the baseline, that is the reference line. Which division is coinciding with the baseline, that division will multiply with the least count of the screw gauge, and we will add to the main scale reading. That's how we can measure very small lengths, and we will see that later. Now we will be discussing pitch and least count. So first we discuss the pitch of screw gauge. So pitch of the screw gauge. So as you have seen with the screw, when we are providing one complete rotation to the screw, the distance moved linearly. That distance is called as pitch of the screw. That pitch of the screw is distance between two consecutive threads. So here pitch of the screw, how to calculate? So here is the zero mark of the circular scale coinciding with the baseline. Now I am giving one rotation to it. Again 0, coinciding how much distance it has moved, that is main scale reading will be taking. So main scale reading is 1 mm. So pitch of the screw equal to 1 mm. So how to define pitch of the screw? Of the screw gauge, it is the linear distance, that is in one rotation how much linear distance the screw has moved, either forward or backward, either in this direction or this direction. So when I am giving one rotation to the screw, that is initially 0 of the mark of the circular scale is coinciding with the baseline. Now I am rotating it by 100 division, that is one complete rotation. So how much distance it has moved, we can note it down from the main scale, and here it is 1 mm. So the linear distance moved by the screw gauge by its screw. The linear distance moved by its screw on the main scale. Main scale, when the circular scale is given one complete rotation, when the circular scale is given one complete rotation. So this is the pitch of the screw. Now least count will be calculating. Least count, as we know, as we have defined it as pitch of the screw divided by total number of divisions on its circular scale. So in this case, pitch of the screw is 1 mm, that is 1 mm pitch of the screw divided by, on circular scale you can see there are 100 divisions, so 1 mm divided by 100. So least count of the screw gauge come out to be 0.01 mm, and it in centimeter it will be 0.001 centimeters. So now let's see how to decrease the least count. So smaller the least count, more accurate the reading will be, more accurate the reading will be. So if we have to increase the accuracy, we have to decrease the least count. So how to decrease the least count? To decrease the least count, either we can decrease the pitch of the screw or we can increase the total number of divisions on a circular scale. So to decrease the least count, either we can decrease the pitch or increase the total number of divisions on its circular scale. Increase the total number of divisions on its circular scale. In next lecture, we will discuss about zero error in screw gauge, whether the screw gauge has error or not. If it has the error, whether it is positive zero error or the negative zero error, that we will discuss in next lecture.